Okay, guys, welcome back to another episode of 461. Today we're going to be talking about smooth muscle, a little bit of energy sources, stuff like that. Let's start with energy sources. You see that? Okay, perfect. So you can get your energy from a few different places in the body. First of all, you have your cytosolic ATP, which is going to give you energy for about 1 to 5 seconds. That's just kind of chilling in the cytosol. Then you have your creatine, phosphokinase or PKA. Phosphokinase. Which is going to give you about 5 to 10 seconds of energy. You have your glycolysis, going to give you about 60 seconds, okay? All three of these are anaerobic, which means they don't need oxygen. Those are great for like sprints, if you're bench pressing, like just getting it off, going for a PR, stuff where you don't need a lot of time, because you can see those don't give you a ton of time. Then you have your aerobic. This is going to use mitochondria, all that fun stuff. And that one goes for hours, okay? That's energy sources. Now we're going to move on to smooth muscle, okay? So smooth muscle can be divided into single unit and multi-unit. Now this is basically just talking about innervation. For example, the muscle fibers, if they're innervated by one neuron, they're innervated by a bunch of different ones. The main difference is that these are all going to contract together for the single. And this one, they're going to contract separate. So your single ones, those will be found in like the walls of organs, stuff like that. Your multi is going to be found in like large blood vessels, the eye, the lungs, things like that. Okay? Now we're going to talk about smooth muscle contraction. As you can see, I left this up here from the last one. This is skeletal muscle contraction. Smooth muscle is mostly similar, a little bit different though. So last time we talked about skeletal muscle contraction, how calcium bound to the troponin moved the tropomyosin, all that fun stuff, right? Smooth muscle actually doesn't have troponin. So what's going to happen is there's two enzymes that you should know. So there's MLCP. That marker kind of stinks. Let's grab another one. Okay. There's MLCP, and then there is MLCK. Now, the most important thing that you should know about these is that MLCK is going to add a phosphate, and MLCP is going to remove a phosphate. Okay. So now we're going to talk about two different kinds of smooth muscle contraction. We're going to talk about phasic and we're going to talk about tonic. Phasic, you want to think of it as like rhythmic. It's contracting like consistently, just boom, 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 boom. Because smooth muscle doesn't really get tired as much. It just goes and it goes and it goes. Otherwise, we would have some serious problems. Tonic contraction is more of a sustained contraction. Okay, it's not rhythmic, it's more just sustained. So let's start, okay? So basically what's gonna happen with smooth muscle contraction, how it starts is you have something called calmodulin, okay? So calmodulin, can you guys see over here? Okay, perfect. Calmodulin, you're gonna have to excuse my artistic abilities. They're not great. Okay, So calmodulin looks something like this. Basically, what calmodulin is going to do is calmodulin is going to activate your MLCK. So what's going to happen is you're going to have some calcium come down, 4 calcium specifically, and calmodulin is going to come down, the calcium is going to come down, and it's going to bind to the calmodulin that is on the edge of, this is your MLCK, and then the calmodulin is going to come down and bind, I'm struggling. The calcium is going to come down and bind to the calmodulin, okay? And what that's going to do is that is going to open it. Open it, or we could say activate it, okay? Which is going to allow it to add a phosphate. Where that phosphate's going to come in is right here. So we're going to, I guess we're going to use blue. We're going to say MLCK. Going to add a phosphate. So now we have an extra phosphate right there. What that's going to do is you're going to go through the cycle, okay? You lose a phosphate, lose an ATP. You still have that extra phosphate right there. Power stroke, okay? Still have an extra phosphate here. Now what's going to happen is dependent on one very important thing, okay? You have an extra phosphate. Remember, we need a phosphate to do the power stroke. So, because we have that extra phosphate from MLCK, let me turn you guys a little bit. We actually have the ability to just skip right on over here and do a whole nother cycle. We skip a whole step. So while we're going over there, ATP is going to get hydrolyzed, and we just repeat the thing. And that is why phasic contraction is all just rhythmic, because you're able to just go and go and go, and you're just removing a step, making it more efficient. However, if our MLCP over there comes in, that's going to make the phosphate leave. If the phosphate leaves, we're just left with our ATP, which is going to get hydrolyzed. We still do the whole process, we just have to do every step, okay? That is your phasic contraction. When you have a surplus of calcium but not a ton of calcium, that's what happens, okay? Now let's move to MLCP and tonic contraction. What's going to happen is you're going to start MLCK, adds the phosphate like normal, calmodulin, all that fun stuff. However, right here, we lose our regular phosphate, we lose our ADP. If we have a surplus in calcium, this is what's going to happen. Okay, so you have an enzyme, you have your MLCP. We're going to draw it like this. So this is your MLCP right here. This is inactivated, this is activated. See this black box right here? That is called your Rho kinase. Your Rho kinase inactivates your MLCP. However, surplus in calcium is going to inactivate your Rho kinase, which allows MLCP to activate. What MLCP is going to do is right here in this step, it's going to come in and it is going to remove your extra phosphate from MLCK. So now we lost our regular phosphate, we lost our extra phosphate, so we have no phosphate. So what's going to happen here is you actually enter a stage called the latch stage. Now normally ATP would come and it would bind to the head of the myosin and detach it, stopping muscle contraction. However, when there's no phosphate, ATP struggles a lot more to find that molecule. So it takes a lot longer to detach the head. So muscle contraction is going to continue. That's called latch, which is why tonic contraction is a continued contraction, because you can't detach the ATP head as much. After that, then it just goes through everything normal, and that is smooth muscle contraction. Yeah, thanks for watching.